Morning, guys. I didn't realise you just jumped in the room. Sorry. Was a little bit distracted there. Well, we're just waiting for everyone to get in, guys, and we'll make a start. I'm going to turn my video off for a second just while I do a few bits. Morning, guys. Welcome to the room. Just waiting for everyone to get in. Don't worry if you can't see anything just yet.
Francisco, where are you? 5:28 a.m. here. Good morning, and thank you for making the effort. How's everything in Paraguay, Francisco? Good of you to join us this morning. Morning, Shane. Morning, Jason. Where are you, Jason? 7:29
PM.
Oh, yeah. I'm guessing Oz.
Morning, guys. You can see us now.
Yeah, I'm on as well.
Can you see us, guys? Give us a shout. Hello.
Morning, Martin. Bill. Guitar. I'm long as I say good morning, it's going to get tedious, isn't it?
There is a poll there, guys. If you could answer that poll, that'd be fantastic. Please just give us an idea of the audience that we've got today. And I think everyone's in the room who's coming. So welcome. I recognise some of the names, guys. So I think some of you have joined us before. Everyone else got sound, guys? You can hear us okay? Not sure what the problem is there, but can everyone else hear us? I'm assuming so. Great stuff. Okay, so welcome, guys, for our online session this morning. This session is high NDM locators. So we're going to talk about RD8000, 8100s, vLocPros, all the high-end stuff. We've got some good information to share with you guys, we hope anyway. I'm at Sygma HQ in Wigan, here all on my own. and Steve's at home down south somewhere.
Bristol.
Bristol. So, quick intro, guys. My name's Pete Ashcroft. Sygma, we're a specialist training provider in utility location. I'm sure most of you here are aware of us, guys. We do the 5-day course at the survey school, the utility mapping survey course. We do like 1-day courses just on RD8000, Cat and Jenny, but we're all geared around utility location. My personal background, very quickly, I guess most of you have heard this by now. I started with Radiodetection when I was about 20 years old. Interestingly, guys, Steve Meller, who's with us, was my boss. He gave me the job all them years ago. So he was, and we're still working together all this time later. So you've got a good experience here, guys. I guess today, lots of experience from both Steve and I. Steve's going to be doing most of the session. I'll be jumping in with a few bits I've got for you as well, guys. So I'll let Steve introduce himself shortly. A little bit on the software, guys. We want to keep these sessions interactive, so ask questions. We will be asking you questions. If you're not sure of something, chuck it in the chat box, and we'll expand on it. There's a bit of a delay on the software, guys. It's about 7 to 10 seconds. So what you're hearing through your speakers now, I said 10 seconds ago. So it makes it a little bit tricky when we ask questions. We've just got to wait. It's manageable. It just means that there'll be a few pauses along the way while I wait for some answers to come in. So I hope you're okay with how the technology works. We're obviously still getting used to this. If you don't know, we're putting all our kind of paid for courses through this platform as an option in the future. So we've been running these free sessions. There's a bit of a benefit to the industry, we hope, but also so we can get used to the platform and get used to how it works and what works best. So I'll hand you over to Steve now. He'll give you a quick intro, and then we'll crack on.
Morning, folks. Thanks for attending. Very, very brief background for those of you guys who don't know me. I started in this business 40-something odd years ago. My dad bought a franchise for the north of England through a company called Electromagnetic. Electromagnetic was a small Bristol-based company manufacturing some fairly Heath Robinson type kit and selling on franchises. So my dad bought the northern franchise and I was bored with school. So I started working with him as a teenager back in the 1970s. Electromagnetic became Radiodetection and they stopped running the franchises and started manufacturing, producing equipment and selling it. So we then went on to do a combination of surveying. I mean, initially my job was surveyor's assistant and then surveyor. And then we started actually promoting the products around the north of England. And then eventually I moved to the States, worked directly for the company. Moved back to the UK in the late 80s and did a whole variety of jobs within Radiodetection, power products, pipelines, product development, training. Sad admission, I know, but this is all I've ever done, and I'm getting too old to do anything else anyway. So, 40-something odd years of using locators. I keep saying I'll get a proper job one day, but I'm getting a bit old for that now. So, this is it, guys. As Pete said, chuck your thoughts, messages, comments in as we're going through, and we'll get started. Pete's going to be jumping in and out, and then he's going to shoot off somewhere. So, if I can get this thing working.
I'll be monitoring the chat, guys. So any questions, throw it in there. I'll keep an eye on the chat, and I'll put them to Steve. There is a few in today, guys. So if you look at the chat box, when you do type a comment in, you can mark it as a question, and that just makes it easier for me to see when using the chat box. So
hopefully I've gone into a tiny little thumbnail type image, which is probably a lot more easy on your eyes. As Pete said, we're covering the 8000, 8100, vLocPro3. You guys might be using other kit out there. Whatever kit you're using, it's going to be very, very similar to this. So, and my laptop is going very, very slowly at the moment. So we're going to cover aspects of things like how to apply signals, the best way of doing it, frequencies, aerials, CD, that kind of stuff. And as Pete said, is there anything as we're going through you guys want to add in, you know, thoughts, comments? You're saying you're having playback problems, Stefan. I don't know about what Jeff's saying, Pete, about being hard to log in today. I don't know if that's just web traffic or I'm no expert on this.
We've had a few issues this week with the login system. I'm still playing around with it, with the notifications and login and stuff. I'll sort that. Don't worry. You carry on. What
we have to assume on these courses, guys, is that you've used the kit quite comprehensively. You've probably had training before, so we have to make some assumptions. Obviously, once we start doing this as a proper online platform, replacing some of the traditional methods of training, we'll have a much better feel for everybody's experience. But so with any of this kit, and you'll notice quite predominantly there's some RD transmitters, but as I said to you a minute ago, a transmitter is pretty much the same as any other transmitter. Frequencies, power outputs, and things like that may vary, but the methodology is exactly the same. So with a TX10 or a vLoc transmitter, whichever you guys are using, you've got generally 4 different ways of doing it. I suppose technically there's 5, but for most people, you're probably familiar with the first, or number 1, 2, and 4. So number 1's direct connection, obviously just taking your red and black leads, connecting up to whatever it is you're trying to locate. Number 2 is signal clamp, which is very useful, common way of tracing things. Number 3, you guys might not have come across it. Some of you guys might have done. Plug connector is useful in places like military sites, big industrial sites. Most of us aren't particularly overly happy with the plug connector because of some of its issues, but it can be useful at times. It just allows you to plug the transmitter into a plug socket in a building, switch both the transmitter and the plug socket on, and that will put a signal into the live LV supply. There are some issues with using those things, but they can be useful. And then induction is induction. Every transmitter is capable of producing an induction signal. If we get time, we'll cover some stuff on induction and nulling out. We'll see how we get on. So I'm guessing you guys are familiar with how to use connecting your red lead to what you're trying to find, black lead to an earth. It's always considered best practice, even though the transmitter produces an AC signal. The reason being is we're going to cover CD later, and that is very important that you do get those leads in that orientation. Probably one of the biggest issues when you're out there is trying to get an earth, and this tried and trusted technique has been around for years. It's never been very well documented. We've started doing some booklets which go along with the training course which show you these little tips and tricks, but water's been, or any kind of fluid has been, a technique for getting earth. So where you can't get the earth pin in the ground, in this scenario here, we're clipped onto a steel gas riser and we're getting an earth. Just any old water will do, or Coke or tea, coffee. Just lay down next to the brickwork so the water soaks away. The obvious thing to say on a hot summer's day, you're going to need quite a lot of water. On a wet day like it is in Bristol today, just find a puddle. That'll do. We're going to cover a bit more about this a bit later on, but earth placement is a very critical part of how your signal is going to be traveling. We were talking about doing another session, and this is day probably 3 from my normal surveyor course, or certainly just a part of it. On day 2, we cover basic electrical theory, which is a very useful part of understanding how a locator and a transmitter works. But what we're doing there is creating a simple electrical circuit. The one thing that's missing, or should have been added onto this slide, is the arrows should always be double-headed. Because it's an AC signal, unless we're using current direction, we don't have any choice in which way that signal's going. So you just got to remember that signals are going to be traveling on other adjacent pipelines. This is also a function of frequency as well. One of the questions we tend to ask, and Pete asks it on his Cat and Jenny courses he runs, where are you guys normally told to place the earth, or if you did training previously, where did they tell you to put the earth? Just if you can pop those comments up, just out of curiosity.
And if you guys have done the Jenny session with me, you'll know the answer to this. So go cheating.
I'm not seeing any responses, but that may be the delay, or maybe mine's not updating. You getting any responses, Pete? I kind of put you guys to sleep already.
They'll come through shortly. Because we've got so many on it, the delay's a little bit longer. When we run this as a paid event, there won't be the delay on it because there'll be much smaller numbers. So just have to bear with us on that.
So Peter, you put 90 degrees furthest away from the line we would like to trace. There we go. So we've got a random mixture there, close as possible, 90 degrees, far away, 90. You guys are putting 90. There is a logic to that, and it was something that was always trained, or it was a technique that we were told to train people on probably 20 years ago. And one of the main reasons for that is the transmitters back in those days had very poor impedance matching. So you very often struggled to get any kind of signal out of your transmitter. So by running your earth away, far away from where you connected on, you are creating more of a circuit. In modern transmitters, a lot more power, a lot more frequency options, and very good impedance matching. That's probably one of the things we get people to understand and do less and less of. What we try to do nowadays is encourage people to keep the earth as close as possible, unless you're obviously going longer distances. The main reason for that now is the fact that you've, in this scenario here, created a much more localized signal source and return. So in this case, you're going to get less on this one and a lot more on this one. Again, this is a function of frequency, but keeping your earth as close as possible. And what the black lead's connected to there is just the frame around, a metal frame around the lid of the valve box, if that was a pipeline.
Steve, is it worth me just jumping in there with my slide for a second and doing that section on the Jenny just briefly to show the dream?
Yeah, if you want to.
Do you want to just turn your screen share off?
Okay.
Second. I'll stick mine on. This is a section I've been covering on the Jenny a little bit, guys. I'll just run through it very, very, very quickly here, guys. So when we talk about earth position, as Steve said, a lot of it depends on what you're doing. The first thing I want to cover just very, very briefly is when we talk about how far a signal will travel. Obviously, we've got frequencies that affect that. But the other thing that affects it, just briefly, for example, is it a pipe or is it a cable? And if you imagine when we put signal onto an insulated cable, because the cable is insulated and the current, if you like, is within that insulation, it tends to travel much further. So it kind of wants to run down that cable and find an earth point. When we put signal onto a pipe, for example, because the pipe isn't insulated, the signal bleeds off quicker. So a few quick examples. Imagine I've got a lamp column here looking from above and a lamp column here and just a very simple cable between them. If I hook up my Jenny to this column, because this cable is insulated, the signal kind of has to run down it to this earth point and then it returns. Alternatively, if I've got a metal gas pipe looking from above or a metal water pipe, if I hook up to this and earth it, because the pipe isn't insulated, the signal can kind of run off anywhere it likes. If you guys have done tracing before, I'm sure you can relate to if you're tracing a metal pipe, as you walk along it, following it, your signal bleeds off quickly. You have to keep upping your sensitivity control. If you're tracing a cable, you tend to get a more constant signal. Also think about pipe size, guys. The bigger pipe, the more surface area you're in contact with ground, the quicker your signal leaks off. Does that make sense to everyone that, guys? Give me some feedback on that. Is it something you can relate to? So let's just go back now to talking about the earth position a little bit more. And again, we'll use a lighting column as an example. if we, again, I'm crap at drawing, guys, so forgive my drawing. If we have a lighting column here and we hook up that Jenny to here, if I put the earth out like this, a couple of meters, what we have to remember is that earth wire is giving off a load of signal like this. So in effect, I can't use my locator in that area. So instead of doing that, if I have my lamp column here, if I hook up and keep the earth very close to it, I can now work around that column with my locator and detect that cable quite easily and work quite close to the column. Can you see that? So by bringing the earth in a little bit closer like that, I can work closer to the column in effect. Again, as Steve said, we don't need to get that distance out there with modern transmitters like we used to. Yeah, exactly, Jez. And also, guys, going back to pipes, think about high-pressure gas pipes. Anybody trace the high-pressure gas pipe? You can trace them for great distances. And again, it's insulated. It's traveling down it further, yeah, okay, because it's an insulated. So when we talk about earth position, though, it does have a more an effect, I would say, on pipes. So if we look at, again, at that gas pipe scenario here, just give me a sec, guys. So this is our pipe. If on the gas pipe we clip on and earth it close, we're actually encouraging more of our signal to jump off early, if you like, so we don't trace as far. If we extend the earth out like this, you know, further away, we can potentially get more signal running down the pipe. Now, a lot of you said 90 degrees, but just think about this. When the earth's at 90 degrees like this, half my signal will run that way and half will run that way. You're effectively wasting half your signal because it's going in the wrong direction. So instead, think about putting the earth at an angle like this, 45, we'd now get maybe 70 going that way. So can you see we can angle the signal? Depending on the angle of the earth, basically, we can direct it. Also think about other things as well. Which way do you want to trace? If I've got a house up here with a pipe going to it, if I put the earth down here, it doesn't really want to take that turn. It wants to carry on down the main. But if I put the earth up this way, it now wants to take that turn. But I probably won't get as much going down the main. Okay, so all these factors are things you need to consider when you're putting that earth position in, guys. Does that make sense to everyone, guys? Do you accept that? You okay with that? So we don't want to go into this on obviously a lot more detail on the courses that we do. Now, the other thing to consider though, guys, and we're going to talk about this later, the downside of doing this, and we've got a classic example of this outside our office here. If we have a metal water pipe like this and we hook the Jenny onto it and earth it down here, what happens outside here is we've got a parallel utility. So the signal now goes down here and it returns along here. Yeah. Now in reality, this should have a stronger signal on it because it's the one we're hooked up to. However, in the real world, this is 1 meter deep. This is 300 mil deep. So what we end up tracing is the wrong service. But if we get the earth and earth it close, as Steve said, to the rim of the box here, we now get a completely different result. We've minimized the signal coming back down here and we locate this one. So there's pros and cons to it. Yeah, if I extend it, I might get more signal, but I'm running the risk of it coming back down over utilities. I guess the important message with the earth is understanding what it does and playing around with it, guys. Okay, is everyone okay with that, guys? Yeah, makes sense. Any questions on that? And if not, I will hand you back over to Steve. That section was from the Jenny bit that we normally do, guys, but I just thought I'd throw a little bit in there.
So I'm getting to advance. The other thing you may find is, like I said earlier on about earthing, you're struggling to get your earth pin in, maybe got no water. Another metal structure, drainage, anything in the ground that's not related to other services that are detectable, basically. So I wouldn't use a comms lid or electric lid, but you can certainly use drainage lids or an old road sign, anything that's in the ground that's going to give you an earth, gully, something like that. But as Pete was just saying about forcing signal in certain directions, if you know or you've got an idea of where you want to trace, although we were saying keep your earth close, and a lot of you guys made some good comments there about it does vary, and that's very true. But if you want to make your earth, make your signal go in a certain direction, move your earth in that direction, Obviously, you'd need to move your cable away because your earth lead cable is going to give up a big signal, or just accept the fact that in that area you're not going to get a very clear signal. I have used fences for earth. I don't recommend it. If it's a short bit of fence, it may well be okay. If it's a long bit of fence, you've got to bear in mind these are always double-headed. So by clipping onto a fence, you're also generating a huge amount of signal, and that fence becomes a very big induction antenna. So that could also cause other issues. And on the right-hand side, feeder pillars, cabinets, anything at all with cables going in and out of it, don't use for earth, and don't use system earths. Always stick with the old earth pin. We always talk about independent earths, anything that's not related to other services. Most surveyors have probably lost the earth pin within the first week, and they've probably got an old screwdriver in there now. But the other thing, these slides show the earth being in the ground that way around. Most earth pins are like an L shape. The reason for that is you stick it in the ground that way around, so it's just underneath the surface, or even just laid on the ground and pour water on it. That's the only downside to a screwdriver. The rubber bit stops it from touching the ground quite so clearly. But
yeah, absolutely, Luke. We actually talked about the last session about using a tree as an earth. Luke's just said he's used foliage as an earth, which is, remember on the last one we talked about that, using a tree
yeah,
and a branch as an earth, Steve.
Yeah, it was on a surveyor course once. We were struggling to get an earth, and there was a tree branch nearby. So I said to the guys, we'll just use the tree. And they looked at me like I was mad. The thing you got to remember is a live tree has got a lot of moisture in it, and that goes deep into the ground. So yeah, you can do that. You're going to probably need to use higher frequency. The lower frequency might struggle, but yeah, you can use a tree root, branch, something like that. So as Pete said, keep your earth nice and close if you want to trace close in. So in this scenario now, you can do a full 360 around that lamp column and work out which way that cable's going. As a generalization, the signal will travel from a lamp column. You've got to bear in mind that this is predominantly aimed at how the system's connected up in the UK. And in the UK, in most residential city centres, you're going to have a cable feeding a streetlight column, which is fed directly off a main supply. That main supply is coming from a substation. So you can, in theory, and I've done it, not always, but you can clip onto a streetlight column. That will put a signal into the service. It will go down the service to a mains LV supply into a substation. And if you had an HV coming down here, that will go back through the earthing, and you'll be able to trace the HV. That slide kind of implies that you'll trace everything, which is not true. But it is a handy way sometimes of tracing other things when you're really struggling. When I was a teenager, we were allowed access. We were given keys. I mean, health and safety's changed a hell of a lot in the last 40 years, but I've worked in a 33 kV substation and was told not to touch anything. I guess you wouldn't get away with that nowadays, but brings us, guys. We've got there a graphical representation of quite a wide range of frequencies. And the one thing that when Radiodetection started producing multi-frequency machines, we said to the software engineers, well, they were hardware engineers in those days, but analog engineers, but nowadays software engineers. We told the engineers just to stick to one or the other, hertz or kilohertz. I'm guessing most of you guys understand this, but when we talk about low frequency, 640, 320, 512, whichever you use, is actually 0.6 kilohertz. Or if we're talking about 8, we're talking about 8,192 hertz. So you can kind of see the confusion when people look at the numbers and they think, well, 640 is a bigger number than 8. Not realizing that it's not actually 8, it's 8,000. This is something which I'm assuming most of you guys understand anyway, but that slide there shows, and the easy one to count is the number of peaks or troughs. So the 8 kilohertz one, there's 8 peaks and 8 troughs there. So if you multiply that by roughly 1,000, you're looking at 8,000 cycles per second. And before we came European in this country, and you probably in the States still have quite a lot of frequencies listed as CPS. And that's exactly how we used to measure it in this country, cycles per second. So basically, if you look at that on an oscilloscope, you'd have your center line. If I could draw a straight line, which obviously I can't because I'm as bad at drawing as Pete. So 8,000 times per second, or 8,192 if you want to be precise, it alternates from a positive to a negative. I'm assuming you guys are still there because my screen just went blank for a second. You still there, Pete?
Yeah, I'm still here.
Okay. We've never counted the others there. If anybody's really bored, you can if you want, but it kind of gives you a graphical representation of, over the same period of time, how much of a cycle has actually occurred. So if you look down at the 640 hertz, it's not even part of a cycle in that same period of time. So up at the 131, or obviously if we had 200k up there, you'd have lots and lots of cycles occurring over the same period of time. So what happens is when you start using different frequencies, you end up with, at a high frequency, lots and lots of energy initially. So that means you've got lots and lots of signal. You don't need a lot of current, you've got lots of signal. But because there is so much energy initially, it dissipates very quickly. At the other end of the spectrum, at the low frequency, 256, 512, if you guys work in the States, we tend to use 320, 640 in this country. Or one of the CD frequencies, basically, that doesn't divide by 50.
Just jump in there, Steve. To add to that, one of the problems that we often find in the UK is that we find a lot of surveyors aren't making use of the lower frequencies. They tend to stick to the higher ones. And as Steve said, what you tend to find with the higher frequencies, they seem to be working better because at the beginning, you tend to get a higher signal, if you like. It seems stronger than the low frequency signal does. But as Steve said, it dies off very, very quickly. The low frequency might not seem as good at the beginning, but it will certainly travel further down there. And I think on the last one we did a bit of a poll on what frequencies people use, and it was interesting how many people just use 33 or above. They don't tend to use the lower range of the frequencies. Back to you, Steve.
Yeah, I'm just seeing what Luke's put there. Sorry, I'm going to lean forward. I can't see it on my screen. Yeah, the thing, Luke, if you're using a comms frame lid for an earth, you've got a very good chance you're going to put a signal into that lid and then possibly into the cables below, because obviously with comms bits in this country, Virgin Media predominantly, their stuff's very shallow, so you've got cables just below the lid, so you're going to get induction into those. Going back to our frequencies and what we've got on screen here. The best analogy that I can come up with is sound. If any of you guys have ever, I don't know, where I live, we often have festivals going on at the rugby club. It's about a mile away, and you can hear the music coming from the festival, but the only thing you can hear is the bass. So the low frequency, and if you've been to a gig or a concert, you can feel the low frequency move in the air because it's a much lower frequency, much longer wavelength. The high frequencies dissipate very, very quickly. It's exactly the same with a locator. It might sound very loud, very clear to start with, but it will dissipate a lot more quickly. The other downside to the high frequencies, and don't get me wrong, they are very useful at times, but the other downside is the fact that they will transfer and cross-induce onto other things a lot more easily. So this symbol here is a symbol for no earth or a capacitive earth. Pete covers on his cat and Jenny course, and we're not coming today because I don't think we've got time. But he talks about PME in this country. which is the modern earthing system in the UK, where you don't technically have an earth at the end of a cable, it's on the network somewhere. So if you put a low frequency onto a cable which is jointed and feeding a load of buildings and it's PME, you won't get a signal traveling down. If you do, then there's a big solid earth. When I started in the 1970s, every house in this country, every building had a big solid earth. You put a signal onto an LV cable and the signal would go down the cable and it would go off down to the nearest big earth, which may be at the first property, maybe the middle property, but you don't get that effect anymore. But what does happen with the lower frequencies, and we look at 8 and 9.8, those sort of frequencies, around about a 10 kilohertz range as being kind of a low to medium frequency. There's no actual definition unless you look in Wikipedia. But those frequencies should continue down the main and not down services, and very unlikely to transfer onto other things. If you start using higher frequencies, you get the bonus, the fact you can actually trace the service to a building. The downside of that is it's going to jump across onto adjacent services, as people were saying before. You can affect that somewhat by placing your earth away from it if you know there's something else there, but this is the downside. This is the main reason why avoidance devices like the Cat and Jenny tend to have higher frequencies. This is something Pete covers on his Cat and Jenny course, but you've got in the Cat and Jenny, the Jenny itself is actually transmitting 33 and 131 kilohertz simultaneously, and the Cat's picking them up in the Jenny mode simultaneously. With the vScan receiver and transmitter, the vScan, which is the vLoc equivalent, simultaneously transmitting 33 and 131. The receiver, you can switch between the two, and other manufacturers do the same thing. But those devices are more designed as avoidance devices rather than surveying devices.
Steve, just jump in. I think it's Rare, as was saying, it all depends on the area, how congested it is, to not forget to try multiple frequencies. Luke was just saying we use different frequencies depending on the utility we're trying to locate. Absolutely spot on, guys. And that's the thing where the training comes in, if you like. It's just teaching people what the different frequencies do, which ones might work, which ones might not work, understanding when to change frequencies and that kind of stuff, which you guys get. And that's the idea of having this IN kit, is you have all these frequencies at your disposal and you can use any one of them.
So when I started in the 1970s, the location equipment that we used back then for surveying had one frequency, 3.4 kilohertz. Or was it 3.142? Can't remember. Anyway, it's around about the 3 kilohertz range. We didn't have another option. And if I'm being honest, I think I've probably located more things deeper with that old analog stuff than I've ever done with more digital stuff. The upside of the digital stuff is you can have a whole load of different options and frequencies. And when Pete was in the office the other day, he had the old RD600 on the shelf behind him. That was the first proper multi-frequency machine that Radiodetection produced in the 1980s. That had 7 frequencies, from 1 kilohertz up to 130 kilohertz on the active range. Nowadays, I don't know how many there are on the 8100. I've not counted them, or the vLocPro3, but you've got 30 to 40 different frequencies. You don't need all those frequencies, but a range of low, medium, and high is useful to have, and then you probably switch off the ones you don't use, or you just scroll past them when you don't need them. So as a general rule of thumb, and don't forget, this is just a generalization. Low frequencies will give you a longer range. You get less cross induction. It's more of a locating frequency. High frequencies, they are very useful. I keep on saying that. You get much more signal on induction. You're more likely to pick up small cables. In the UK, most small comms cables, Virgin Media is an exception, but BT, they're not usually earthed at property. I know in the States that's different. In this country, you don't generally get earths on the end of small cables. So that means you're going to have to use high frequency to get a signal to travel down them. And it's back to Pete again. you're going to go a little bit on signals and aerials.
Turn your screen share off, Steve.
I should have done that, shouldn't I?
Yeah.
Sorry.
Hi guys, back to me. So we're going to cover a little bit now on antenna settings, in particular distorted fields and peak and null, and then Steve's going to carry on covering some of the lower frequencies and current direction. Before I start with my slides, guys, I just want to ask you a question. Can anybody tell me the physical differences between a peak aerial and a null aerial? Not what they pick up or what they detect, but the physical differences. If you looked at them both, what difference would you see? Anybody tell me that?
I'm just looking at Neil's comment, Surin. Yeah, oh, that's an old one.
Maybe should have been a bit clearer with my question, but I'm going to run through it with you anyway, guys. When you have your locator on peak, and this is the same way that a CAT works, it's basically using exactly, yeah. That's what I was trying to get at. Probably asked the question badly, Paul, but yeah, it's the actual orientation. So a peak aerial is horizontal, and a null aerial is vertical. Some locators might be a little bit different. When you're locating a signal, you've got your. I'm used to the old stuff like Steve, so I call it a needle, but you've got the you've got the signal strength meter, should we call it? But you'll hear me calling it a needle anyway. And as you walk across that signal, that magnetic field, it peaks. You get the highest point, and then it drops again when you go past it. So I'm sure you guys all understand that you're looking for the high signal, and that should equate to where the utility is. So what the aerial is actually doing is the signal response you get from your locator is actually based on the angle of the magnetic field passing through the antenna. Okay. So I'm just going to turn my screen share off so you can see me a little bit here, but just imagine that coil there. That's what the aerial is at the bottom of the locator, just so you can see me bigger. If you imagine my knuckles as being that coil, and I place that, it's all reversed on here, it's moved the wrong way. If I place that in the magnetic field, it passes through it. And that's why, guys, I'm sure you're aware that if you put your blade of your receiver in line with the utility, typically you don't get a signal, okay? So it's got to go in 90 degrees, and then the magnetic field passes through. And the way that it works is this, guys. When the magnetic field, the angle, is horizontal, the maximum amount of signal can pass through that aerial. So that's where we'll get the highest reading, where it's horizontal. If the angle of the magnetic field was on a 45-degree angle like this, let's say we'd get 50% passing through. And if the angle of the magnetic field was vertical like this, none of it would pass through. Okay, does that make sense, guys? Just want to get some input into this. So each section I move on to will only make sense if we understand each part leading up to it. Okay, so that's how a peak antenna is effectively working. That's how a CAT works. So if I just put my screen back on with you again here, what you can see here is the peak antenna, the horizontal antenna, and here it's, whoops, get my pen going. Can you see horizontal, 100%? Over here, it's on a slight angle, so it's a weaker signal. Yeah, cool, guys. So let's effectively put that in the real world. This is a magnetic field coming off a cable. If I put the aerial here, I'm going to get 100%. If I put the aerial here, can you see it's 45 degrees? I'm going to get 50%. If I put the aerial here, again, 50%. So that's why I get that peak response. What I also want you to see from that diagram, guys, is the highest reading, yeah, the 100%, which relates to the horizontal band on this situation is directly in line with that cable, okay? Let's now look at distorted field, guys. So in an ideal world, the magnetic field coming off an underground utility should be cylindrical, just like you can see there. However, quite often it gets distorted. Distortion is caused by many things, bends, T-junctions, multiple utilities. There's a whole host of things that can cause distortion, guys. And a distorted signal would look like this. Now, once again, using our peak antenna, if we put the most horizontal part is probably about here. So that's going to give me my 100. If I put the receiver directly over the cable, as you can see here, the angle's kind of 45 degrees, so 50. and over here 50. So my response now is like this. So I'm going to mismark the cable. Anybody ever had that before, guys? I'm sure you have, where you've marked something up and it's in the wrong place. You get a mislocate, and it can vary. Does it make sense so far, guys? I will keep asking you a bit of feedback during this so we can keep moving on to the next section. Okay, so that's how we can get an inaccurate locate from a distorted magnetic field. Okay. That's how a CAT works. So we do a lot of training with the guys on site who are doing excavations, and they'll often complain that they've mismarked things. Okay, now the difference between a null aerial, guys, is a null aerial is actually vertical. Now, if anybody knows with a null aerial, what you're actually, if we forget the arrows for now, because I know we've got arrows on there to make our life easier, but if we go back to the old-fashioned locators, like the old RD400s, the null basically is where you get the minimum response. So the idea of a null antenna is that you get signal when you're away from the cable, and then as you come over it, the signal drops to its minimum. So we get no signal where the cable is. And the reason for that, and I hope you can relate to this, can you see the null aerial is vertical? Okay, so once again, I'm just going to turn my screen share off so I can use my knuckles to show you this. Imagine the null aerial being like that. If the signal was now vertical, the magnetic field angle was vertical, I'd get 100% reading, wouldn't I, from the null antenna? But when this magnetic field is horizontal like this, how much will pass through? 0. Yeah. Any other angle like that or like that, I would get a response from the aerial. But when it's completely horizontal, I get a complete 0. And that's what your null antenna is referring to. So here, again, where the magnetic field... Oh, I've done it again with my pen. Hang on. Let me turn screen share back on. So let's go back to here again now and look at the null antenna. Here we go. So again, the antenna's here. The magnetic field's horizontal, 0. But if I put it over here, it's not, it's passing through it. Makes sense? So let's look at the real world again. If I put the null antenna here, because it's horizontal, I get 0. But if I put it over here, because it's no angled, I kind of maybe get 50. And then over here, again, sorry, Mr. It get 50. So the null response is more like that. Okay. So does everyone understand how a peak and null antenna works? Okay. And do you also see, guys, that the peak and null antenna is going to point to the same place? In effect, it's picking up the same thing. A peak antenna is giving you the strongest response where the magnetic field is horizontal. Okay. And a null antenna is giving you the minimum response when the magnetic field is horizontal. Okay. Have we all got that, guys? Okay, so let me ask you a question then, guys, and forgive the delay. When we have a distorted signal then, if the peak and null antenna are effectively pointing to the same place, why do they give different positions? Yeah, what's the answer to that, guys? Why, if they're actually pointing to the same place, do they give different positions on a distorted signal? Can anybody tell me? See if anyone can get that one. I'm not sure if you don't know or you're just not answering yet, or it's a delay on there, guys. So I'm going to carry on and see if any answers come in. And the reason for it is the position of the antenna. So if we look at a typical locator, we're going to ignore the top aerial for now. Your peak antenna, which is horizontal, is here. And the null antenna is here. Okay. Okay, got that, guys? So in other words, the null antenna is higher. All right, so let's have a look at this magnetic field again. On this one, which is undistorted, the peak antenna is detecting this band, if you like. That's our 100%. The null antenna, which is higher up, is giving the same position. Even though it's higher up, the angle is still horizontal passing through it. But let's look at a distorted field. Look at the difference. The peak antenna is here, but the null antenna is higher up, so it would equate to here. Does that make sense, guys? If you look at it, the deeper something is, the further away those horizontal bands come. And because the peak and null antenna are at different heights, that's what gives us that offset. Does that make sense to everybody? And this is also, guys, me and Steve spoke about this last week. This is also why sometimes the peak and null response from different locators is slightly different. It depends on the distance between the antennas. Some are closer than others on it. Okay, so is everyone okay with that, guys? It's obviously quite technical, this bit, but I hope you understood that. So that's why when we have a distorted signal, guys, what we actually get is this. We get the true position, the peak position, and the null position. Okay, and one of the interesting things is, guys, you know, we get this for beginners quite a lot, is if peak says it's here and null says it's here, a lot of people think it's in between. And it's not. It's on this side of the peak. So you kind of get cable, peak, null, or cable, peak, null. One thing that you will always notice, guys, is which is always furthest away, null. And the problem with that is that because we use these little left-right arrows on null, people often think it's more accurate, and it's not. Okay, it's not. It always goes further away. There was a rule basically saying that you could kind of work out this position by some theories say half this distance, some say a third of this distance. I would not bank on that, guys. There's been many a situation where that's not been true. You'll usually get that layout, but this to this, I would honestly say I'd be very cautious about putting any exact figures on that distance. I hope that was useful, guys. I hope that made sense. And now you understand about the different peak and null antennas in the machine. Some of the locators work slightly differently, guys, but that's in effect what we get from distorted signals. So just to summarize, if peak and null are in the same place, it generally means we have an undistorted signal. Generally means we're going to be accurate. And that's why we do that peak and null test before we take a depth reading. If peak and null are separated, we've got a distorted field. And then we need to look at correcting that, guys. This is the other thing that we find, is that people kind of accept that and start guessing at where it might be. Let's look at changing frequency, changing earth position, changing connection points. But the first thing we must do is try and correct that signal, and not just locate with a distorted signal, if possible. So hopefully that makes sense, guys.
Just before you go back to your one where you drew your triangle, Pete, on your distorted field, because remember, yeah. So as I'm looking at it, the one to the right-hand side would actually be narrower than the one on the left-hand side. You remember?
Absolutely. And this is another point, guys, that we talk about in more detail, because there's multiple ways of looking at distorted signals coming off it. We use peak and null as one. But what you tend to find with an undistorted signal, you get an equilateral triangle. I'm crap at drawing triangles. With a distorted signal, you might get more kind of like that, if that makes sense, guys. And we can do this with a basic cat as well. We can look at the angle of drop-off. Just before I pass you back to Steve, Steve's going to start talking now about current direction and current measurement. I'm not sure if you guys have used these before. So anyone used current direction out there? And we want to talk about the importance of these high-end features on your locators, because again, we feel that they're underutilized. So I'm going to show you an example, which I've already touched on, and then Steve's going to relate to this as he talks about the next section. A very simple example, a plan view looking from above. I've got my pipe, if you remember. Okay, and I've hooked my transmitter up to the pipe and put the earth here. Okay. And then I've got a parallel utility. Now, in theory, with a locator, whatever we hook up to should give us the strongest signal. If we've got a return signal that's bled onto something else or coming back down something else, in theory, that signal should be weaker. Okay. So what we've got here is we've got signal traveling down here, and we've got it kind of coming back down here. We're going to keep it nice and simple, guys. Yeah. If both those utilities were at the same depth, we would generally get a stronger signal on this one. However, that's not always the case, is it? So like I said before, let's imagine that this is a meter deep and this one is only 300 mil deep. What could effectively happen now is that this one from the surface is giving us the strongest signal. So we end up tracing the wrong thing. Okay, this is a problem that we have. This is where current direction and current measurement come in to help us figure this out. And I'm going to pass you back to Steve, who will expand on current direction and current measurement. So I hope that section was useful for you guys that I've just covered. You ready, Steve?
Yeah, sorry about that.
Your screen share back on, mate, and it's back over to you.
Yeah. I don't know if you guys can still hear me, but it's hanging at the moment. Apologies for this, it's just suddenly gone greyed out. Are you still there, Pete?
Yeah, mate, still here. You still there?
Yeah, mine's just hung for some reason. Sorry about this.
You can see your slideshow, mate, Tom. I can see you.
I can't see anything.
Do you want to jump back in?
Hang on a sec, I'll just see if it works. It's just, I can't get rid of the, there we go.
Yeah, it's working, mate.
Yeah, okay. My second screen's just hung for some reason, but never mind. We'll carry on, guys. Current direction, signal direction, or signal select. So RD, Radiodetection, developed current direction. It was originally in the old RD400 range, so 20 plus years ago. And one of the main issues we always had, and this mostly came about through working with AT&T in the US, was trying to actually make sure you were tracing the right thing. And over distance, even the lower frequencies, you did get to a point where you started to get return signal, and it was sometimes very difficult to determine which was the right one. So RD engineers developed current direction, and it was a methodology where you could actually trace out normal, but you had a separate identifier. I don't know if you guys, and my second screen's locked, so I'm not sure I'm getting any responses, but I don't know how much you guys use CD, SD. CD and SD is pretty much the same thing. SD is VVAX's version of current direction. They call it signal direction. And SIS is signal select, which is a much wider range of frequencies doing pretty much the same thing. Very useful in congested areas or for long distance tracing, and you want to make sure you're on the right thing. A sideline, one of the things I do in my business just to keep the bills paid and keep the grey matter working is that I do cable fault detection, and I would never consider taking a machine out to do a cable fault without CD or SD or SIS. And the main reason for that, the first and number one rule of cable fault detection is that you locate the cable, and you've got to be on the right cable. I've had pretty much stand-up arguments with people who are convinced they know where the cable goes. And when you've got a CD or an SD or an SIS signal on it, you can categorically say you're wrong. The cable doesn't go there. It goes where I'm telling it goes. So you can only apply current direction or signal direction using direct connection leads or a clamp. SIS on the VVAX, you can, and they probably won't like me for saying this because they do actually sell an SIS clamp, but you can't actually get the SIS frequency to work using a standard clamp. You can't with the RD kit. It's got to be a dedicated CD clamp. And that's it. You guys
Steve, just want to jump in a second, guys. Just to be clear, for anyone that doesn't know, is CD's a frequency in effect, and it's a low frequency. So the same limitations apply. You have to be able to get that frequency onto the utility. And to do that with a clamp, you need that big whacking clamp. Even with connection, you know, treat it as a low frequency. You need a good connection.
Just keep talking to me, Pete. I'm just going to have to close down the browser because it's gone off my screen altogether now.
Oh, we can still see you a little bit.
Can you?
Yeah.
I can't.
You're going to have to relog in if you leave. Sorry about this, guys.
I can't screen share. It's just gone off.
Yeah, just relog in, Steve. I'll hang on till you log back in, guys. Just bear with us for 2 secs. If you want a quick toilet break, just run to the toilet.
Yeah, my browser's hung.
We can still see you, Steve, but you might want to leave the room and just reconnect.
I can't leave it now. I'm going to have to close it down manually.
And he's gone. There we go. You should just have me now, guys. Any questions, guys? While Steve's just reconnecting, he's going to run through current direction with you when he gets back. But as I just mentioned before, we have to understand that it is a frequency. You are still there, guys. Yeah, I'm just hoping nobody else is disconnected. We've got 62 on, and when there's 62 on, the delay is a bit worse. So when we're running these for real, if you like, there's a paid course, we'll be limiting it to kind of 4 or 5 people, which makes it a little bit easier. He's back in the room.
Hello, hello.
The problem we have is that Steve doesn't mix very well with technology anyway. Did you hear that, Steve? Sorry.
Nothing to do with me, it's the system. Bring back Windows 95, that's what I say. Okay. Yes. Sorry about that, guys. So if you've got the RD kit and you're going to use CD on cables, you're going to need one of those things. The downside to that thing is it's only 3-inch diameter. So if you're working in areas where you've got larger cables, the VVACs make a larger 4-inch 100mm CD clamp. The only downside to any of this is it's all very expensive accessories. None of these manufacturers send it as standard bit of kit. But so on the RD kit, 8000, 8100, you're going to scroll down to the frequency. You're going to choose. They tend to use in the US 512, 256. And we started talking about that when Pete jumped in with some other observations. One of the main issues with any low frequency machine in this country or anywhere in Europe, I'm guessing you guys know this, electricity is generated at 50 hertz. So if you get any multiple of that, it's called a harmonic. So any multiple of 50 is kind of easy to work out: 100, 150, 200, 250. So if you get a multiple of that, then you're going to get a harmonic. So around about the 512 or let's say 256 region. If I can get my pen working again. So fairly simple math, you multiply that by 5, you've got 250. It doesn't take a huge amount of frequency shift to get that up to close to 256. You shouldn't really be getting 51 hertz, but you're probably not getting true 50 hertz in this country. So what we tend to find is around about the 256 frequency in this country, in Europe, we get a huge amount of interference from cables, just standard power interference. And it's not really interference, it's just picking up the harmonic. And conversely, in the States, because of electricity being generated at 60, you start multiplying that by 10, 11, 660, 600. So you're getting close to the 640 range. So in the US, we tend to not use anything that's close to being divisible by 60, and the same in the UK and Europe, or anywhere where it's a 50 hertz system, it's a multiple of 50. Yes, Pete. Yeah,
I'm just going to say, so that's why, guys, when you hear low frequency being used in the States, they generally use 512 and 256 for the CD, and in the UK we use 640 and 320. I hope that makes sense. That's why we have different low frequencies for the US and the UK. Is it worth? So the clamp basically would go around an insulated cable when it's exposed. So easy example is, imagine a trial hole with a cable exposed in it. They don't work around lampposts. There was a big thing that went round about this with the bloody gas industry. They started calling them bloody column clamps and putting them around columns, and they don't work. The only way you'd use it on a lamp column is by going into the column, taking the door off, and then clamping around the cable inside it, which most people aren't qualified to do out there. So it's got to go around the cable. Generally speaking, that cable has to have an earth ball thing, again, to create that circuit. You sometimes get around that using high frequency. Back to Steve again, who carry on with the CD.
So the key thing with CD or SD or SAS is ensuring you are actually getting the signal in the right direction. I know it's a bit of a contradiction in terms because you don't have a directional signal. Basically, you've got two signals being transmitted simultaneously. So this is why we're talking about 512 and 256. The carrier frequency is the higher of the two, and the identifying frequency is the lower. So you'll always find it's half the carrier frequency. So 640 in the UK or Europe, if you're using that one, half of that's 320. On the 8100, if you guys are using that one nowadays. And the other thing is you've got to make sure you've got the right model. I would go to full screen, but I'll probably mess it up. So RD8000 PDL. In the 8000 range, there's only two machines that have CD. That's the PDL and the PTL. There's quite a lot of different models of 8000, but there's only two can actually receive CD. The TX10 transmitter is the only transmitter you need. I know, again, there's a wide range of transmitters, but I'll stick with the high power transmitters. A TX1 and a TX5 look exactly the same as a TX10. The 1, 5 and 10 is the power output. And if you've got a TX1, you don't have CD. So, and you've only got 1 watt of output. If we've got time, we'll talk about transmitters and how to get more power out of them, as well as messing around with earths and earth placement. There are ways of getting more power out of a transmitter if you're struggling. So you choose your CD frequency, and you've got to make sure that your current direction is in the right direction. If this is working. Actually, I'm going to skip to that slide and we'll come back to this one in a second. The next one's a video from RD just explaining a little bit about it. I'll turn up the volume as well so you can actually hear it a bit more clearly.
Current direction allows you to identify your target line amongst a number of parallel utilities by applying a specialized current direction signal from the TX transmitter. A directional arrow is displayed on the locator screen, confirming that you are tracing your target line. An icon on the locator screen shows you which frequencies support current direction. It is always good practice to reset current direction before use. This can be done by a sustained press on the F key from any of the current direction frequencies. To verify current direction, You can build a small circuit using the red and black direct connection leads from the TX transmitter. Set a CD frequency on the transmitter and point the receiver toward the red clip. The CD arrow should be showing current flowing toward the red clip. If this is not the case, use the current direction reset option, and the arrow should then start pointing in the direction that the current is flowing. To verify, switch to the black lead. The directional arrow will now reverse.
Turn back one slide, guys. That's an old.
Can I just jump in a second there?
Yeah, sure.
Just turn your screen share off for a sec. So guys, just to jump in before Steve gets to the technical side of it, remember the example and the problem that I gave you before. I'm just gonna redraw it very, very quickly. This will hopefully help anyone that's new to CD understand what it's doing. You remember the problem we had? We had this pipe here that was a meter deep, plan view, and then we had this other utility that was quite shallow, for example. And then we'd hooked up to this, and we had signal traveling back here and back here. Now we're trying to locate that pipe. The problem we have is that we've got multiple signals and we're not sure which is ours. Okay. So whereas before, this one had the strongest signal on it, what will happen now, the arrow you just saw on the locator will point away from the transmitter. So when you put your locator over this one, it'll point away. Any return signal will have an arrow pointing back. So even if I had multiple utilities, all with a return signal on it like this, every one of them would have an arrow pointing back. So let's say, what we got there, four signals. One of them would point away, the rest would point back. And that's how we start identifying that we're on the right target line. Is everyone with us so far on this, guys? Are you understanding the benefits of CD? And Steve's going to, again, talk about it in a little bit more detail. On that note, guys, I'm sorry, I have to leave you. I have to go to a rather important meeting, so I'm going to leave you. Steve will update you on the rest of the sessions that we've got at the end. If you've got any feedback on today's, guys, drop me an email. I hope it's been useful so far, and I'm sure you'll enjoy the rest of it. And I'll pass you back over to Steve, and I'll see you all later.
Thanks, Pete.
Back to you, Steve.
Just while you've got me in large screen, it showed on the RD video pressing and holding the frequency key on the 8100 to reset CD. On the 8000, it doesn't do that. What you have to do is you have to go into the submenu, I'm seeing this backwards, I'm guessing you guys are as well. Submenu, momentary press, and you scroll until you see CDR. That stands for current direction reset. The one thing I don't think it made clear on that video is whenever you do a current direction reset, you've got to make sure that your back is to the transmitter. And this bit, it did say point this towards a red lead, but you've got to make sure that this is always pointing in the direction you think the cable is going. So what we tend to do is check it on the red lead initially, but you've got to make sure that that is pointing in the direction of the cable or the pipe, not back towards the transmitter. If you do a CD reset with it in the wrong direction, you're going to get the arrows the wrong way around. Pete's last little scenario, you kind of twig straight away that something's not right, because you'd have loads of away facing arrows and one facing back, and that would kind of make you realize that CD is the wrong way around. But the easiest way is always on the red lead. The difficult thing with CD is when you've got a signal clamp. The main reason for that, a signal clamp can go that way around a cable or that way around a cable, and it does make a difference. On my clamp, I've got a little arrow which I've put on it using a permanent marker pen, which is fine so long as I don't change transmitters. But so that way, with a signal clamp with an arrow on it, you always know to point arrow downwards as the cable goes into the ground or goes away from transmitter. If you're not sure, your best option is to put it around a cable, where you can actually see where the cable is going and make sure the arrow is pointing in the right direction. Let's get the screen share back on again. So the thing with the 8100, it's very quick to do a CD reset. With the 8000 PDL or PTL, you've got to go in the submenu to do it. On the vLocPro3 series, it's a momentary press. I think it's I key and then momentary press of antenna key, if my memory serves me well. Having been in lockdown for a while, it's been a while since I've been using the kit, so that little slide there, this is the universal symbol for a transmitter. Except I've lost my drawing tools. Here we go. So that's the universal symbol for a transmitter. So this would be your red lead connected to a cable. This would be your black lead connected to earth. And this is simulating an excavation, trial hole, cable pit, whatever, where you've actually got 3 utilities. Let's say they're all cables, they're all the same color, they're all the same size, and you want to know which is which. So you walk across it with your receiver, you might be getting multiple signals. Usually with CD and low frequency, you're going to have your strongest signal on this one, but possibly you're getting fairly similar signals. The benefit of CD is you're looking at your screen and you can have your arrow pointing away on this one. And on the other 2, your arrow points back. If you guys are using the vLoc2, you don't have an arrow, but you do still have the same thing. So in your compass direction indicator, you've got 2 hemispheres around your compass direction. And basically that equates to this hemisphere lighting up, and arrow back relates to this one. So instead of an arrow, it's just the semicircle hemisphere, whatever you want to call it, lighting up as your direction indicator. On the vLocPro3, you've got a nice big arrow shows up on screen, so you can't miss it. I don't know if you guys, I'm assuming everything's back up and working again now. I don't know how much delay there is on there. How much you guys, or do you guys use CD a lot, or at all, or never? One of the questions we asked at the first session we did last week was, what frequency do most people use for tracing? And I guess it kind of depends on what you're doing, but do you guys have a preferred frequency? Do you use CD? While you're scribbling your answers down, if you can, if you notice on this trial hole, excavation, cable pit now, you've still got 3 cables. You would assume that the middle cable is still the right one. As you can see from that scenario there, they've now changed position. So this is the one with the arrow pointing away. The other 2 cables, arrows pointing back. This is one of the benefits of CD, and this is why I always use it on cable fault detection. Only because every time you do a cable fault, and there's a very good book, if you hunt it down on the internet, written by an old CGB engineer, Barry Clegg, and he opens up by saying there are only 3 types of cable fault: a complete open circuit, a complete short circuit, and everything in between. And 90% of what we trace is the third one, the ones that are in between. But the most important thing is you've got to know where that cable goes, and you've got to be 100% certain you know that cable is the right one and it's the right route that you're tracing. Otherwise, it's a complete waste of time. So that's why I use CD a lot. It's also, it just takes away the confusion. There will be times when even CD causes problems just because of other signals, mostly 50 hertz or 60 hertz in the US. So Stefan, yeah, you've got a normal signal clamp, so if you're using RD kit, you can't apply CD. If you're using VVAX kit, you can apply SIS. Yeah, Martin, Bill, yeah. CD is not something you have to use all the time. It's one of those, like every other tool in your armory, it's just a useful thing to have. You may be on sites where you don't often need to use it. On the RD8000, 100 and the TX10 with the latest version of software, you might notice that there's a 4 kilohertz and 8 kilohertz CD. That's very, very useful when you can't get the low frequencies to travel, or you're struggling with 50 hertz or 60 hertz interference. If there's anybody from VVAX on here, they can tell me the highest frequency on the vLocPro3 with SAS. I think it's around about the 35 kilohertz range. So they've taken SAS beyond the normal frequencies up into the higher frequency range. And that's again down to one of the problems we tend to have with the low frequencies. When I was talking about frequencies earlier on, low frequency is always preferable in identifying or tracing situations where you've got congestion. But the downside is 50 hertz or 60 hertz interference, and you need more power from your transmitter. So you may find that you're trying to use low frequency or CD and you're just not getting a clear enough signal. So both RD and VVAX have now made receivers that can receive higher frequencies and still have the benefit of CD or SAS, which is the same thing.
Current direction.
So this is very similar to the slide that Pete then drew in. To answer your question, Jason, will CD work on HV? Yeah, you're going to have a CD clamp, that's the only thing. And some HV cables are too big. This is something that we said all along when RD produced the CD clamp initially, that the clamp was too small. So VVAX have got a 4-inch, I believe, 100mm CD clamp and an SAS clamp. Receiver clamp, you can get a CD receiver clamp, or you used to be able to, but I'm not sure you can anymore. You can certainly get a CD stethoscope. In this country, although we've used it numerous times for cable identification, it's not an approved method. The main reason for that is there are instances when you can get it wrong. Certainly with a signal clamp, you can get the clamp the wrong way around. That's the simplest way of getting it wrong. So in the UK, and different countries will have different legislation, but in the UK there's only one approved method for cable identification, and that's putting a transmitter across 2 cores, which is shorted out the far end, and using a very simple receiver with a small stethoscope type aerial, which you run along the cable and you pick up the twist of the cable, the lay effect as it's called. So we don't tend to use CD as an identifier, although you can. Mark, you're saying yours is frozen. I'm guessing you're talking about your screen, but Stefan, to answer your question, I have got the RD price list, but I think you're looking around about £600 to £700 in the UK. So I'm guessing that's if you're overseas, sort of exchange rate at the moment, it's probably around about the same, $600–700 or euros for a signal clamp. So the scenario I've got there up on screen now, your transmitter would have been applied down here somewhere to this one with your earth pin, and you're getting return signals on underground surfaces and on crash barriers. Any long metallic structure just acts like a normal cable or pipe, any conductor. So you do get signals from crash barriers, it's a known issue. If we get time, we'll talk about that a little bit later on. But pretty much every machine nowadays has got current measurement, and it was initially sold as a method of identifying before current direction came out. If you guys got any specific questions, I know I'm skipping around subjects only because mindful of time, we ran out of time last time. So if you've got any questions, by all means pop them up on screen and I'll try and answer them as we're going through. So the idea of current measurement is you're looking at the signal that you've applied, and the machine's popping up on screen with an indication of which has got the most current. So in the scenario there, it's not the most accurate graphical scenario because it probably wouldn't be very accurate anyway, but the idea is you've got your target line down here, you applied your signal. This is not using CD now, this is just using CM, current measurement. And you've got a stronger signal here than on the one you think it is. And you've got a slightly weaker signal over here. So the idea with current measurement is you're actually looking at the current response and saying, well, that's 13. These are made up numbers, by the way. That's 27 and that's 19. If those utilities were about double those distances apart, then that would probably be okay. But that close together, I certainly wouldn't rely on current measurement. It is a very useful function, though. Again, we use it on cable fault detection, pipeline monitoring, and just looking to see where signals split. So Pete does quite a lot of sessions on Cat and Jenny throughout the week, basic type tracing stuff. And although you don't with the standard Cat, you do with the V-scan receiver, you do actually have current measurement on the V-scan receiver. But on the standard Cat, you're just looking at signal strength, and you're looking at where your signal's changing and splitting. So the idea is you put a signal onto whatever you're trying to trace, you pick up a receiver response, and then you look at your current. When I was a teenager in the 1970s, we didn't have current measurement. We had the old-fashioned needle responses. We had a big moving coil meter with a gauge on it from 0 to 100. And we were taught to religiously set the thing to 70%. So you set your needle to 70% and you watched it. And if you got any change of signal when you went back over it, that indicates that something's happened to your current. So it may drop down to half, it may drop down even further than that, it may go up. But once you saw that change of signal, you knew something was happening. On the modern receivers, you've got current measurement. I haven't got an 8100 with me, so I've only got a standard 8000. So on the 8000, your current measurement is indicated down here where depth would normally be shown. And to switch between the two, you press and hold the aerial button. So if you're not seeing current and you want to get current on screen, you hold the aerial button down and it switches over to current. If you've got an 8100, which Pete had in the background when he was with a Sygma, on the 8100, you've got current and depth shown simultaneously. So on this side, where you've got frequency on the 8100, it alternates between frequency and current, and on this side you've got depth. And on the vLocPro3, you've got depth and current again simultaneously shown on screen. So as I said to you before, the idea is it shows you where your signal's going and what's happening to your current. I wouldn't use it as that slide says if the things are close together, but if you've got a reasonable separation between multiple utilities and you're still getting signal on 3 or more of them, theoretically the strongest amount or the highest amount of current will be the correct pipe or cable. Yeah, Bill, you've put on there, you've used it for locating cable joints. Yeah. So you're following your signal. Your signal will always change when you get some sort of connection on a cable at a joint. Sometimes it's very obvious, sometimes it's not. But this scenario or this slide here explains how current measurement works. So you've got a 90% signal strength reading on your screen. You've got a depth of 0.6 and your current measurement is showing 25 milliamps. You've walked down the route of the cable and it's gone a lot deeper. It's gone down to a meter down. So your signal strength's dropped from 90 down to 30%. If all things are equal, your current doesn't change because that's how it does it. It's calculating. And don't forget, it's a made-up number. You're not actually picking up 25 milliamps because that's impossible to actually measure. But it's giving you an indication how much current is being given off by the pipe or cable. In that situation there, its signal strength dropped dramatically, but your current stayed the same. If, and this is maybe what Bill's talking about, if this was a cable and we had a joint here and we had a cable going up over there, your 25 milliamps, if all things are equal, could end up being 12.5 going that way and 12.5 going that way. It's again something we tend to use where cables are jointed and you're looking to see where your signal is and what's happening to your signal. So in simple terms, your signal's coming down here, 25 milliamps on a plastic insulated cable that Pete was talking about. You're going to get very minimal loss over distance unless it's really long distances. So a few hundred meters, you're not going to see a massive amount of loss of signal unless there's a joint or a connection or something's happened to it. So you can monitor which way your signal's going by looking at current measurement. I'm hoping that makes sense to you guys. It's also something that we use on pipelines. I spent a lot of work in the 1980s and 90s with a guy who was the guru in this country for pipeline corrosion control, a guy called Graham Goosey, worked for British Gas and lectured all over the world on corrosion control. If you guys have ever done any pipeline monitoring, the old tried and trusted technique was what's known as a Pearson survey or CIPS, close interval potential survey, where you're putting probes in the ground and you're looking at the Earth's soil potential, which with a coated, protected pipeline, and I can't draw straight lines. So you've got your pipe, which is just like a cable, it's insulated, and it's steel and it's welded. So electrically, it's as good as you're going to get. But let's say a farmer's put a fence post, because in this country, it may be the same in the US, but in this country, a lot of damages tend to happen on farmland, even though the farmers know they're there. So he's stuffed a fence post in the ground and he's taken off a big chunk of the insulation here. So let's say this was per kilometre. The old-fashioned technique would be that you'd walk along, two of you, with your ski poles, your probes in the ground, and you're looking at the potential measurement between the pipe and the ground around it. This was obviously very time consuming. It took a lot of man hours to do this, especially on long distance pipelines over distance. So we learned very quickly that you could use low frequency and use current measurement to look at a linear loss of signal. So if you've got a chart of loss over distance, it tends to be reasonably linear. These numbers are a bit low, but let's say for simple maths, we'll stick with them. 100 milliamps, 1 kilometre, 80 milliamps, 2 kilometres. So this is fairly linear. We're getting 20 milliamp loss per kilometre. And the obvious thing about this is you don't have to walk the entire route. You jump in your car, van, truck, and you drive to a road crossing or a point where you know roughly that you're another kilometre away, or in the States, miles away. And you suddenly find that between 3 and 4, at our 4 kilometre point, we've now only got 20 milliamps. So at this point here, we've lost 40 milliamps. So if you map this in loss, 20 milliamps, 20 milliamps, 20 milliamps, 40 milliamps. So you now know that between kilometers 3 and 4, we've got a significantly higher loss of current. These numbers will be high, but anyway. What you can then do is you can then walk that kilometre looking for any obvious indications, farmers putting fence posts in, it could be another utility crossing it. You can use an A-frame, a PCM device. Every manufacturer, most manufacturers anyway, make machines for picking up these contacts. Even just a standard locator will probably pick it up. So that's where current measurement is very, very useful. I've done lots and lots of tracing on that. I don't know if you guys do pipeline monitoring or anything like that, but that's where you'll find current measurement useful. We debated where to put this slide in, and it's been moved around a few times. This was before the 8000 came out about, so it was in the old RD4000 days. I went over to Scotland with a surveying company who were being tasked with remapping Scottish Water's assets, and they'd had some issues with where they'd marked where they thought the pipe was, and it turned out not to be correct. So they decided it was a training issue. There's a combination of factors. I went out with this surveyor, pretty experienced guy. In the UK and the US, Metrotech was a very common manufacturer. Metrotech are now owned by VVAX, big manufacturer, very well respected in this industry. In the US, with big wide open spaces, the old Metrotech 810 was a great bit of kit. Very widely used. If my memory serves me well, it was 83 kilohertz, so quite high frequency, auto gain. And in the UK, a lot of guys working in the water industry were using Metrotech equipment. In tight Glasgow streets, same as anywhere in the UK and Europe, the high frequency and the auto gain wasn't quite so good. So I took this guy to one of the sites he'd had an issue with, and I just left him to. I said, show me what you're doing. So he connected his transmitter up as the slide shows there. He put his earth into a grass verge over here. So going back to what we'd said earlier on about earth position and what we cover on day 2 of my survey course, talking about electrical circuits, where's the electrical circuit there, and what's the issue with that? I'm assuming you guys are still there because I can see some numbers up on screen. So, the other obvious thing to say about water pipes, and certainly in the northern part of the States, this was an issue that I found, and I'm guessing if any of you guys are from the northern part of the States, you'll know this, or Canada, because of the permafrost and temperatures in winter, you're going to have water pipes at significantly greater depths. So I moved south when I lived in the States. I moved to Houston, so freezing up of water pipes wasn't so much of an issue. Yeah, Jez, you're absolutely right. So you clip onto a water pipe, and this is what this guy did. I think it was a hydrant or a valve, too long ago, I can't remember. And it was close to the road edge. And the other thing to say about water pipes, in this country, there's a very common ductile type pipe, and it's called a tight-on connection. So I'm a bit like Pete, not very good at drawing. So you've got like a male-female configuration, and inside the bell housing is a rubber O-ring, and your other bit of pipe sits inside it like that. It sits on that rubber O-ring. So you've got an issue with electrical continuity. Ductile is not a very good conductor. So let's say these are 5-meter sections of pipe. The other issue, besides the fact we've got these rubber O-rings, this pipe is bare metal anyway. So your signal travel, yeah, Neil, you're right. You've got your earth near to other surfaces. This is a major issue with this. Remember AC, alternating current, something we cover on the surveyor course, explaining about AC and DC, not the band. Probably find it more interesting than me rambling on, but anyway. So we've got signal going in all different directions. We can't stop it from doing that. And because this is a bare metal pipe, instantly we're getting loss. We're getting signal return going across here. There becomes a point where the path of least resistance for this current, whichever frequency we're using, is to actually travel down adjacent cables. So we've now got signal traveling in both directions on adjacent cables. Let's say, for simple maths, we're getting 100 milliamps from our transmitter, and if all things are equal, that means we've got 50 milliamps going in both directions. And let's say, again, for simple maths, at each joint we lose 10 milliamps. We've straight away lost 10 milliamps at the first joint. You can see what's going to happen, guys. And that's assuming we're getting no loss, which is also not true, but for the purposes of this, it just makes it a bit simple. Yeah, Michael, that's the problem. Well, that was his initial problem, combined with the fact he was using 83 kilohertz and auto gain. So if you guys have ever seen the old Metrotech, you've got a center sprung needle, and it beats one side and it continues to the other side. So as you go across it, you're looking for that needle to center out. You have no gain control on that thing. The machine automatically adjusts the gain. So as he was tracing on down here, he was getting the correct location. The machine's automatically adjusting the gain, so he's not noticing the fact that the signal's dropping. You get to about this point, and his signal starts to do this. Because what he's got over here is he's got about 5 milliamps returning, but it's not just returning, it's traveling in all directions on the other cables. In this case, let's say electric cable. So as he started to gradually head across the pavement in this direction, I said to him, "You've got to stop now." He said, "Why?" I said, "Because you're no longer following the cable, the pipe." He said, "I am, because that's what I connected onto." I said, "Firstly, you've got another valve hydrant up here." He said, "No, that's offset." I said, "Mate, this is the problem you're having. You're using high frequency, and look where you put your earth." Michael, you said use the gully. That's exactly what we did. I'm just going to stand up a second, so you read, Neil. Yeah, Neil is saying about depths being unreliable. If we get time, we'll talk about depths and depth measurement. The main factor with any machine, it doesn't matter which one it is you've got to have a nice, clear, undistorted signal. And you guys understand about peak and null, peaks being through with you. One of the simplest ways of working out distortion, I have no allegiance to either manufacturer. I've got mates who work for both companies, BVAX, RD. I'm just going to put the classic screen on here. So if you guys can see that screen, although there's no signal at the moment, one of the easiest things you can do with this thing is just look at the color of the bar. So when you have got signal, if I can get something that will give me any kind of signal at all. So with this one, you're going to see a red screen, a blue screen, or a green screen. If you've played around with these things, you'll know this. The red screen means bad signal, distortion. Blue screen means a little bit of distortion, and a green screen means you've got a very, you might not be able to hear me with that. A green screen means you've got a good signal. It's a very, very quick and simple way of checking for distortion. You can do the same with the RD kit on peak and null by verifying your peak and null positions. It's entirely up to you which machine you prefer. But that's key factor with depth. You may well be right in what you're saying, Neil, about repairs and connections. The other thing is, we do cover this later, but while we're talking about it, obviously size is important when it comes to depths, because your machine is calculating to the center of the magnetic field. RD used to make a device called a vector bar, which was a great bit of kit. And the first thing that you did before you started tracing was you put the size of the pipe in. So if you're tracing a 24-inch pipe, you told the machine it was a 24-inch pipe. The machine would then compensate for the the 12 inches between there and there. I don't know what you guys do. On most survey drawings that I've seen, companies put on their drawings that depth to EM is here, depth to sonde is here, and depth with GPR is there. You have to bear in mind that if some of you guys did Mike's GPR course yesterday, that might not be always strictly true with the GPR, because you might actually be getting the bottom of the pipe, not the top of the pipe. And similarly with a sonde, if you push it a long way, the thing tends to coil up sometimes, and you might end up with your sonde up here somewhere. Of course, that's important if you're in a large 3-foot diameter or 1 meter pipe. But the thing I'm guessing you guys do know, this is always, besides distortion, this is the critical thing. So you need to know that. And most surveyors tend to just put down whatever the machine says, but the bigger the pipe, obviously the bigger the error. So if that was a 36-inch pipe, you've got 18 inches. For those of you working metric, that's about a half a meter discrepancy, if my maths is correct. So a 1 meter diameter pipe, metal pipe, big pipe, is going to be 500 mil out, always on the depth, if the depth is correct. Anyway, going back to our little scenario here. This is where I've taken over RD8000, which had CD on it. The first thing, as Michael said, moving the earth, the gully, did help a little bit, but it didn't solve the problem completely. We then put my RD8000 on it with CD. We still had the same scenario where the signal eventually did transfer enough onto the cable that we get a stronger signal. The other thing you remember is the cable's shallow or shallower than the pipe. So a water pipe down around about 800 down, electric cable 400. It doesn't take long for that signal to suddenly become stronger. But with CD, even though it's an AC signal, this is when you are looking at your arrows, and this is where you are getting this effect. So your arrow indication is always going to be pointing away. Your return signal is always going to be pointing back. So even though we ended up with stronger signal on the electric cable, we knew it was the wrong one because of the arrow direction. And this is again where current direction, signal direction, or SS is very, very useful. There is an old tried and trusted technique which I was taught as a kid. And when I worked at Radiodetection, it was electrification those days, when we had all our kit sent up, it was a surveyor kit with every conceivable accessory you could imagine. And one of the most useful bits of kit was a 300 meter extension cable. And what that allows you to do is that. So talking about my day 2 surveyor course and electrical theory and electrical circuits, what's your electrical circuit now? On the previous 2 slides, the electrical circuit involved using the earth ground as part of your circuit. And this is the bit that people tend to forget about. You've put your red lead on what you're trying to find, you put your black lead in the ground to the earth. That whole mass of ground is part of your electrical circuit, and anything else that happens to be in there also becomes part of it. So if you're working where there's old tram lines, railway lines, that's part of your electrical circuit. Fences, even a large vehicle parked alongside you will carry some of that signal and become, if not part of the circuit, certainly inducing some signal. But what happens in this scenario here, guys? Yeah, Bill? It's what we call a double-ended connection. It's the old-fashioned, but probably best technique for tracing anything you could possibly ever want to trace. There's obvious downsides to it. Firstly, you need a 300 meter cable or longer. Secondly, you've got a long bit of cable with trip hazards. There's one very good reason why we ran it across the road and down the other side, and that's to get it away from all the other services, because that cable is generating a huge magnetic field. If we're using low frequency, as you know from experience or what we've been talking about, that the lower frequencies are less likely to induce into things. In the old days of the analog kit, they used to say, move the cable 3 times the depth. With digital kit, I would say make sure it's further away. That cable, within reason, can be as long as you want. I had a guy got his own survey company. Being on my course, he rang me up one day. I think he was trying to find a pumping main, rising main, or in America, a force main. And I said to him, have you got 2 points of contact on the pipe? He said, yeah, but they're about 600-700 meters apart. I said, well, get yourself about 1 kilometer of reasonably good quality copper cable. Doesn't have to be very big, but you're not going to get much loss down that cable. So in this scenario here, your circuit is down through your pipe and down through your return, and obviously alternating 8,000 times per second if you're using 8 kilohertz. But this is the scenario now. You don't get as much loss through the joints. You will still get loss, but let's say our 50 milliamps, you might find now it's around about 45 milliamps, 40. You get to a midpoint, 35, and then your signal starts going back up again. As far as an AC circuit is concerned, that's pretty much connections at both ends. You might not always get all the way back to your full amount of current because of little bits of loss, but you'll end up with this scenario where your signal starts to increase as you get towards your next connection point. So if you imagine this is now 1 kilometer apart and you've got 1.2 kilometers of cable, I know it's time consuming, and this is something the surveying industry doesn't have a lot of, but if it's something you've got to find, and I did the same thing at GCHQ down in Gloucester, tracing cables. If it's something that you've just absolutely got to find, this is by far the best way of doing it. You guys might not have tried it because you're probably out of the cable. I believe, I was told by Pete in the last course, RD stopped making that long cable. I mean, you can go out and get one yourself. I joke with guys on my course that one day I'll start a web shop. I'm going to call it Steve Surveyor Shop. And all these things you'll be able to find. I've been saying that for about the last 15 years and it's never happened, so it probably won't happen in the future. But I believe VVACs are now selling a long extension cable. Most bits of kit come with a 5 or a 10 meter extension earth, which is sometimes handy, but you obviously can't do that over long distances. But it's one of those things, like every other tool in your armory, it's handy to have one, stick it in your car, your truck, your van. Keep it with you because you never know when you're going to need it. I've used it in the last couple of years, probably once or twice, but it's a useful thing to have. And if you can't get it from a manufacturer, you can go online, buy yourself some pretty decent single core copper cable. Obviously, the longer it is, the further your signal's going to get. Could you use 2 jennies, one at either end? No. The main reason for that, Neil, is what's known as a beat frequency. And you'll know this when you come across it. If you've ever been on site, you guys tracing out together and you're both using 8 kilohertz, what happens is the 2 frequencies end up beating. And what happens then is your signal is a bit like a Jenny signal. It starts, an old-fashioned Jenny signal. It starts pulsing. And the problem with using 2 Jennies is you've still got the same amount of loss in both directions. So this is still, albeit time-consuming, and you do need the cable, a much cheaper way of doing it. Locatable rodder. Yeah, you're talking about putting a locatable Cobra type rod down a non-metallic pipe, I guess, and connecting on both ends. Yeah, that'd work great. The other thing is you can work a lot deeper with these type of techniques because you're not relying on earth. The earth is no longer part of your circuit, it's the cable. So if you're struggling with things that are deep as well, this will help dramatically in that scenario. So that is a double-ended connection, guys. old-fashioned, tried and trusted technique, the only thing you need is a very long cable. So look, maybe in the next 15 years in Steve's surveyor shop, I seriously doubt it'll ever exist, but or go to the manufacturers and pester them for one, or just look online and get a long bit of cable on a drum. In this country, you can get empty drums from most higher stroke tool supply companies and just put a load of cable on it. The thing to say with doing that, this is something I noticed with the RD kit, you do need to uncoil all the cable because the RD kit struggles with the inductance of the cable wrapped up, so you've got to take it all off. It's a bit of a pain. The VVAC transmitter cope's a lot better. What happens with the RD kit is you don't get, even though you've got basically as much as you can a perfect circuit with the RD kit, you don't get a lot of current. So you've got to uncoil all the cable. I know that's a pain, but could I potentially make a long cable? Yep, absolutely, Luke. You can stick it on an old toilet roll. It has to be a very big one, but any old bit of wood drum, anything, you can wrap a bit of cable around. So most of these in the UK, you can get from the likes of CPC, Tool Station. They sell empty drums, and then you can just put your own cable on it. Flexible tracing wire. Yeah. What we do on these courses, and it's the same as the survey course, we kind of teach you the purest ways of doing it, and it's the sort of thing you don't need to use every single day. You might not use it more than once or twice a year. You guys might, same with CD, you might find that most of your tracing is done fine with 8, 9.8, 33, even higher frequencies. So what we're trying to do is give you some pointers on how to, if things are not working out how you want them to, or you're struggling, or you're thinking, how on earth am I going to find that? So any pipe where you've got 2 valves, a valve and a hydrant, 2 hydrants, 300-400 meters apart, this technique, obviously assuming it's metal, will work perfectly. You just need a big long cable and hoping people don't trip over it. We're getting close to 2 hours, guys. We've got some slides to carry on with. It's entirely for you guys. I'm happy to carry on. We've still got 53 in the room. I'm guessing most of you guys are still awake, hopefully. If you want me to carry on, we'll do a little bit more. If numbers start dropping or you guys are going to go off and do other things, then we'll wrap it up. Stick your comments down if you want me to do a few more bits on. We've got some stuff to do on sonding capacitance. We don't have to do it, it's entirely for you fellas, but if you're happy to carry on, we'll carry on. If last session we didn't realize, but there was a 2-hour limit on the software and it cut us off, but Pete's now upgraded the software, so if you guys are happy to stay, I'm happy to talk. I have got another session, so I can't talk too long, but I'll do a little bit more with you guys, and then we'll. In fact, let me just check, because my apologies, guys. I can't remember my second session starts at. Yeah, it does. It starts at 1 o'clock, so I'll do about another 10 or 15 minutes, guys, and then I'm doing utility networks at 1 o'clock. So you guys are welcome to hop back in again and join me, or if you want to shoot off and enjoy the rain in Bristol. Well, hopefully you got a bit of better weather. But so this slide you're looking at here, we cover on days 2 and 3 of my surveyor course doing the electrical circuits. So we get guys drawing out electrical circuits, and the good thing about some of them is they don't always work because the circuits aren't great. I'm just reading Francisco's comments. I don't know if you guys have got contact through Pete, so he would have sent you the joining instructions for this. So I guess your best option is to email Pete with your questions and what you want to know a little bit more about. And any comments as well, guys, send them off. So you've got your transmitter, which is in this scenario your battery, and you've got your red and your back leader, but you've got no connection. So it's not a completed electrical circuit. So theoretically, there is no current flow. But this is a technique that's again been around for years. It's never been very well documented by the manufacturers. And it's something that we show people on even a standard cat and jenny course, just guys out there every day working in the streets using a simple cat and jenny. The symbol there that you're seeing hopefully on screen is the symbol for a capacitor, and that's where you've got two conductors separated by an insulator. And also, the higher the frequency, logically, the more often it does it. So you've basically got your red lead, and in this scenario here, that is a satellite or aerial cable running down the wall of a building, plugged in the back of a TV or an aerial satellite receiver box. And underneath the insulation is a conductor. Underneath the red cable is a conductor. So you've now got two conductors separated by insulators. So you've now got a capacitor. Stefan, to answer your question, I think we might be doing one more, but you'll have to keep an eye on Pete's LinkedIn page, and I share it on my LinkedIn page as well. So you guys are on LinkedIn, have a look. Or I'm not sure if he's putting these up on this Sygma website, but it's certainly on the LinkedIn pages. So as you can see from there, we're using water and earth. For this to work, you do need to use high frequency, so you're probably 33 kilohertz and above. And what's happening there is the signal is capacitively discharging from the red lead into the satellite or aerial cable, which is then going into the back of a TV or aerial receiver, which is plugged in the mains. So it's a very simple way of tracing electric supplies. So you find a cable on the outside of a building, which is going into the building, which is plugged into, that could be an outside light, it could be an aerial cable like that. If you're in the middle of a city centre, there could be an outside light on a building, and you wrap your red lead around the outside light. You've got inside the light a conductor. You've got the gap between the red lead and the light as an insulator, so you create a capacitor. So that's what we call capacitive coupling, and this is again where your high frequencies are very useful. In this country, we've got a lot of cables, BT cables, communication cables running down wooden poles. You can do it anywhere in the world where you've got a cable running down a pole that's got a guard, a shroud around it, so you can't get a clamp around it. The red lead, although you can't see it up here, would be just tied in a knot round there, just so that it hangs down close to the cable. You've got your earth pin in the ground down here somewhere. And as part of the electrical circuit, you need two earths. So there's one of your earths there. This cable goes off and eventually goes back to a cabinet somewhere. Because in this country, there's a BT cabinet or a comms cabinet. There's an earth there. That's the universal symbol for earth. And there's an earth here. And there's your two earths. And the signal is transferring from the red lead into the BT or comms cable through capacitive coupling. You may notice when you're looking at your transmitter that you're only getting 2 or 3 milliamps. You don't need more than that. A couple of milliamps will suffice at high frequency. And the one thing with all these transmitters, if you press the arrow up button to increase the amount of current, although the bars increase, if you notice the current doesn't increase, then all you're doing is overdriving the transmitter and running your batteries down. It won't damage your transmitter. All it's doing is just eating your batteries. Another point to make, guys, and I'm sure you know this, pretty much all surveyors do, with any of these transmitters, always get rechargeable batteries. I'm not trying to sell the manufacturers more expensive systems. It just saves you a whole load of hassle. With modern rechargeables, you get a lot more capacity than you can get out of alkaline batteries. and you'll find the batteries last a hell of a lot longer when you're on site. And for whatever reason, and none of the manufacturers seem to be able to tell us this, the battery indicators seem to be a lot more accurate with the rechargeables. If you've ever had the misfortune of using NiCads, as you remember that far back, NiCads were terrible. But modern lithium ion or nickel metal hydride batteries, rechargeables are brilliant, so I would strongly recommend you do that. And you don't need to drive lots of current when you're doing this, because the high frequency does it for you. Pete's covered quite a lot about peak and null aerials. The only thing to say is you've got an 8100, I don't know what you guys are using. You've actually got 5 aerial settings. You really only need peak and null, or peak or null. This is very difficult to explain, and it's not easy to explain when you're actually on site, but that is the aerial configuration for an 8100. A lot of guys like using peak and null because it shows that on screen. So you're getting your peak indication using your bar indicator and your signal strength. So your bar indicator, numbers, and your null is indicated by the arrows. The thing you have to be aware of, and I've had to go to RD about this, is that with an 8100, you've got peak plus. When you get used to it, it's very, very good. But initially, if you swap from an 8000 to an 8100 and you press the aerial button and you go from peak to what you think is peak and null, it might not be peak and null, it might be peak plus, where the arrows are actually mimicking the peak. So what you've got to do when you've got an 8100 is make sure, if you think you're in peak and null, you are actually in peak and null. And to verify that, when you're in the peak and null setting, so you've got both peak and null indications on screen, you hold down the aerial button for about a second, and in the bottom right hand side here, it'll say null or guide. Because when it's in null, you then know you're in peak and null mode. And when it's in guide, it's in what they call peak plus mode, where the arrows mimic the peak. I know this probably, if you're used to it, makes perfect sense. And if you're not, it probably makes no sense at all. But basically, you can be confused by the fact you're getting peak and null in the same place when you're actually not, because you're not in peak and null mode. My biggest complaint, and I've had to go RD about this, is the box shows exactly the same symbol, whether it's in peak plus or peak and null mode. You can change that in the sub-menu. You can go to the sub-menu and change which one it defaults to, but just get used to the fact if you just change over from an 8000 to an 8100, you may not be in peak and null mode, you might be in peak plus. Guidance mode, which they also have in the peak and null mode, just to confuse you even further, is basically Metrotech mode. If you guys have ever used a Metrotech, it's exactly the same display as a Metrotech. They obviously can't call it Metrotech mode, so they call it guidance mode, but it does exactly the same as a Metrotech. It's a center position needle. If you go left, you get a constant signal. If you go right, beeping all the way around, and it behaves exactly the same as a Metrotech. Auto gain. If I were you, I'd switch it off unless you like Metrotech mode and you're in a fairly uncongested area. Broad peak, I use it all the time for cable fault detection, but if you're not doing cable fault detection, I'd turn it off. It says there, used to detect and trace very weak signals, for example, deep utilities. This was true in the analog days. This is not true in the digital days. In the old days of the electrolocation kit, we used to press and hold the depth button, and that used to switch it onto the bottom aerial and keep it on that. So it went into single aerial mode. On the 600, you used to be able to switch it into single aerial mode. So with analog machines, it was very, very good. Unless you guys know different, I've never managed to get it working very well on a digital machine, but it is useful for cable fault detection. So on my machines, it's usually left switched on, but you guys can switch it off. Some people prefer to look at the peak and null separately, so it's entirely up to you whether you have peak and null enabled together, or you just have peak and then you have null. It's entirely up to you. The one thing that Pete didn't explain with a null aerial, I'm going to use his knuckle scenario here. So this is obviously directional. It can only detect a signal which is coming from this orientation or that way. But a null aerial, it's omnidirectional. The signal can be coming from any orientation flowing through the aerial. This is one of the other issues with a null aerial, the fact that it's omnidirectional. It has no direction. The way that you get the arrows on the screen is little sub aerials either side, which indicate the position with the arrows. But as Pete also said, a true null, and this is what a lot of people don't realize because they tend to just look at the arrows, a true null is where the signal response goes to 0 and then rises up to a high setting. So if you're not getting a true null, it's dropping down from maybe 80% down to 30%. It's not a true null, even though the arrows might seem to be pretty precise. You want to see that signal disappear completely and then rise back up again. As I said earlier on, this is all the purest stuff. This is not, you guys probably don't have a lot of time to do this. So you got your arrows, you got the impression of a much greater accuracy, and the response is quicker. If you've got an 8100, you're going to get arrows on peak if you're in the guidance mode. If you've got an 8000, you've just got a single response which rises and then falls, hence the peak terminology. And the variation can be quite sluggish when it's deeper. The other thing is that's also a function of frequency. So with lower frequency, you're going to get a slower response than you are with a higher frequency. I'm not going to cover it again. This is a classic example of distortion, and it's predominantly in power mode. In the background there, you can see a scar. The power reading is giving me two indications, about a foot, 300 mil, either side of the actual position. So there is actually nothing out there apart from that's where the field is. Directly over the scar, nothing. Signal again. This is not a fault of the machine. This is just where the magnetic fields are. Every machine will give exactly the same indication. And that is where we were tracing. Two triplex 11 kV cables and a low voltage. Side by side, in a trench, indications in the wrong place. This is one of the downsides of using power. Useful frequency to have, but very commonly nowadays, huge amounts of distortion. A lot of guys are getting this where you're getting readings in the wrong place. The interesting thing about that side is when we use radio and we induce onto those cables, the indications were spot on. So traditionally, we only switch between peak and null to verify depth. And when the peak and null responses weren't in the same position, we didn't bother with depth. That's probably a much better indication than what I tried to show you, holding the VVAX receiver up. So you can see from the classic response, a red indication. So if you guys have played around with this, it's very quick and simple, although that's in null mode. You've got a red response indicating distortion. So if that was green, you know you've got a good signal, clean indication. Blue, I found it's very, very close to being spot on. The other thing I've noticed with the VVAX, and you guys, if you've switched around between different machines, and like I said earlier on, I have no allegiance to either company. I've got friends who work for both manufacturers. I would always recommend, before anybody shells out the hard-earned cash on this equipment, borrow a bit of kit from me, the manufacturer, and try them both side by side. That's always the best way. See which one you prefer. They probably wouldn't like me to say that, but that's the way I'd do it. Try both machines side by side. I do find with the vLocPro3, just that color screen makes it so much quicker to look at distortion levels. So we are kind of running out of time, guys, and I need to have a quick break before I start my next session. Most of the manufacturers, certainly the PDL, PTL range of RD kit and the vLocPro series, will do depth in power and CPS frequencies. If I were you, I'd ignore it. We spent a long time convincing the engineers to take depth off power, because in the old days with the analog kit, the depth button just worked. So you could press a depth button and it would work in any mode, even though it was useless in power and radio. It did give an indication. So we managed to get them to take it off in the digital days, and then they put it back on again. So I would strongly recommend that you don't use depth in power. And if you guys have used CPS, again, we're running out of time, but CPS stands for Cathodic Protection System. It's basically just a power harmonic. So its inaccuracies are going to be probably as bad as power inaccuracies. Every manufacturer sells it as a way of finding high pressure pipelines, which in the middle of nowhere it is. But having said that, in the middle of nowhere, a standard cat would find a high pressure pipeline in power or radio mode. So CPS does not work well in congested areas because you'll just pick up power signals. So in the UK, that's going to be 100 hertz, and in the US, it's going to be 120 hertz. And in the congested area in the middle of a town centre, city centre, on 120 hertz, you're going to pick up power cables. So active tracing of high pressure pipelines is always your best option using a transmitter and low frequency. And if any of you guys are remotely interested, that's how it calculates depth. So obviously the distance between the two aerials inside the machine are fixed, and your depth is proportional to that. So as it gets deeper, that ratio is going to change. As it gets shallower, obviously the converse happens, and you've still got to remember the size of your pipe. Small cable, it doesn't make a massive amount of difference between there and there, but a large pipe, obviously it does. Guys, I'm running out of time. I appreciate you guys have stayed to the end. We've still got 44 people on there. Thanks very much for your attention. How do you check the distortion in power and radio? In power, you've got to kind of accept the fact there's always going to be distortion. What you can do, Jeff, is you can put it onto one of the harmonics. So with the vLocPro and the 8100, you can switch to 150, 250. The machine then acts like it's picking up an active signal. So you then get peak and null. You can get the color display on your VVACs. All you can say is generally expect to find distortion in power and radio. You can't really check in radio, but certainly use the harmonics on the 8100 and the vLocPro series machines if you want to see how really badly distorted it is. What I'd normally say is modern cables, it's going to be very badly distorted anyway. So thanks, guys. Any comments, please stick them on the feedback, which I don't know much about, because PC expert on this. I'm going to have a quick 5-minute break, grab a cup of coffee. If you guys are staying for the network session, you're a braver man than me, having to put up with me for that length of time, but thank you for your attention. I think we're going to do one more of these before hopefully everybody's out of lockdown, and stay safe, guys, out there. Have a good one, guys. Well, yeah, I had to. I'm running out of time. I need a pee and I need to. Yeah, I think so. I ended up with that 44 at the end. I think so. And I find it. Right. Is that the one that says on air? Oh, no, I'm still on air. Yeah. How do I stop sharing this? Okay.